In Young's double slit experiment, fringe of certain width are produced on the screen kept at certain distance from the slit. When the screen is moved away from the slit by 0.1 meter and the fringe width is increased by 5 into 10 power minus 5 meter, and separation between the slits they given us 1 millimeter. We need to calculate the wavelength of the light used. See this diagram now. Drawing, this is a screen, we are having slit S1 and here the slit is S2. Our aim is to calculate the wavelength of the light. This is the light, wavelength of the light. This is screen. Okay, we are taking the distance between the light and the screen is here D. Okay, and distance between the two slits, this as small d. Our aim is to calculate here. If you are passing a light, there is a central spot as well as slit. Here there is a light passing here. Here also it is coming like that. There may be many slits passes inside the screen and it touches the screen, and we will get the bandwidth here, fringes here, dark fringes, then light fringe, then dark fringe, like that is going on. Our aim is to calculate the wavelength of the light used. Here they given the fringe width increases, that is nothing but this is the fringe width, this is beta value, it is increases by 5 into 10 power minus 5 meter. Okay. What is the formula for fringe width? Fringe width beta, representing the symbol for fringe width as beta, lambda d divided by d. Our aim is to calculate lambda, the wavelength of the light used only. Now beta is equal to d. Here they given when the screen is moved away from the slit of 0.1 meter. Now the screen is moved here of distance of 0.1 meter. Okay, 0.1 meter. So now from this distance it is moved from some distance of 0.1 meter. So I am going to add here d plus 0.1 meter. Now our aim is to calculate from here to here. So d plus 0.1 meter here. And the wavelength, we don't know the wavelength, lambda. Our aim is to calculate lambda only. Now divided by d. And next line they given this fringe width. When we increase 0.1 meter, the fringe width also increases. If you are increasing the screen here, the fringe width is also increases. It is increased by 5 into 10 power minus 5 meter. Okay. Now you substitute this value here, lambda, beta for beta, lambda d divided by d plus 5 into 10 power minus 5 is equal to multiply this one, lambda d divided by d plus 0.1 lambda divided by d. Now here we are having lambda d divided by d, and this side also we are having lambda d divided by d. So this get cancelled. Our aim is to calculate what is the lambda, wavelength of the light used. Now lambda is equal to d into 5 into 10 power minus 5 divided by 0.1. What is the distance they given? Small d. The distance between the two slits is here 1 millimeter. Okay, this separation between this slit is here 1 millimeter. So the d value they given us 1 millimeter. Now this can be represented as lambda is equal to d value 1 into 10 power minus 3 into 5 into 10 power minus 5 divided by 10 power minus 1. Okay. Now when you are cancelling this one, you will get the wavelength of light used is 500 nanometer. So the wavelength of light used here is 500 nanometer. Option 3 is the correct one. Equivalent resistance between the point A and B is. Here they given one circuit diagram. What is the equivalent resistance between A and B? We need to find now. Now when we are saying like this diagram, upper loop and lower loop means you must consider from here to here it is a parallel circuit. Okay. Now here A, this point is A, this is B and here C. I am representing this point as an D and here E and this is F. Now this can be redrawn as this point as A, this point is B now. Now keeping this point here, this is C and this is D point and here it is E and this point as F. Now you see this diagram, compare these two diagrams, this is same only. See, C is connected to D and C is again here it is connected to E. Here also C is connected to E and D is connected to here F. Here the D is connected to F. So this part becomes as a parallel circuit now. Now we know the formula for resistance in parallel. Resistance in parallel is Rp, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here we are having 3 resistance, so I am representing here this is R1, R2 and R3. Here they given the ohm as 4 ohm. This is as 4 ohm and here also it is 4 ohm. This series is also 4 ohm and here we are having 4 ohm. Okay. Now this is a parallel circuit. This is R1, R2, R3 now. This can be written as 1 by 4 plus 1 by 4 plus 1 by 4. Now this is of 3 by 4. So 1 by Rp is 3 by 4. And Rp, resistance in parallel circuit is equal to 4 by 3. So now this whole circuit we are having the value as 4 by 3. 4 by 3. Okay. Resistance in parallel. When the resistance is connected in parallel, we will write the formula as R. That is when the resistance is connected in series, we will write the formula as R1 plus R2. Now this is resistance in series, this resistance as well as this resistance. Now I am considering this resistance as an R1 and this resistance as an R2. So here we are having 4 ohm, 4 plus R2, 4. So from this series resistance we are getting 8 ohm. RS, series resistance is 8 ohm. Now what is the total resistance, the total equivalent resistance between the point A and B we need to calculate. So total is equal to resistance R is equal to RS plus RP. Resistance in parallel plus resistance in series. So resistance in series is 8 ohm plus parallel is 4 by 3. Now this can be written as 24 plus 4 divided by 3 is equal to 28 divided by 3 is equal to 9.3 ohm. So the equivalent resistance between the point A and B is 9.3 ohm. So the answer is here option 1, 9.3 ohm. Number of electric field of lines emerging out from 4 coulomb charges. Now this is a 4 coulomb charge. The material consists of 4 coulomb charge. How many number of electric field lines are emerging inside the material we want to calculate now. So here number of, our aim is to calculate the number of electric field lines passing will represent the symbol for number of electric field lines passing through a material is pi is equal to Q enclosed divided by epsilon naught. Epsilon naught is nothing but that is the permittivity of free space. So this can be now written as 4 coulomb of charge is enclosed here. So 4 divided by 8.85 into 10 power minus 12. Okay. Now this is pi, number of lines passing. 4 divided by 8.85 into 10 power plus 12. And here when you are dividing this one, you will get 0.45 into 10 power 12. And this can be written as now 4.5 into 10 power 11. So the option is here 4.5 into 10 power 11. Number of lines are passing through the 4 coulomb of charge.
IUPAC name of the following compound is. First we have to write the compound in simplified form. CH2 double bond CH single bond CH3 bond CH2 Br. First we have to find the parent chain. Here we can number it from 1, 2, 3 or else we can number it from 1, 2, 3. In this 2 manner we have to fix where the functional group is attached is parent chain. So we have to fix this chain as a parent chain. This is a branched chain. So the correct IUPAC name is 3-bromo-2-methyl-propene 1, 2, 3, 4. Methane, ethane 1, 2, 3. Methane, ethane, propane. So there is a double bond is there. So we call it as propane. Otherwise we can give a name as 3-bromo-2-methyl-prop-1E. Choose the correct increasing order of boiling point of alkyl halides. When alkyl groups reacted with halogens, there is an intermolecular force of attraction is there between this alkyl and halogen. This intermolecular force is stronger when the size of the atom is increased. Here the halogens are fluorine, chlorine, bromine, iodine. In down the group, the size of the atom increases. When size of the atom increases, the intermolecular force between the halogens and alkyl group also stronger. So this leads to the higher boiling point. So the order of boiling point is increasing order of boiling point is RF minus RF, RCl, RBr and Ri. So the option 1 is correct. Here the nitrile group which is reacted with Grignard reagent in presence of ether which gives a product A, which is on further hydrolysis this gives a product B. The reaction is CH3, CH2, C triple bond N. This reacted with C6H5 MgBr. This nitrile group, here the carbon has a partial positive, nitrogen has partial negative. So this methyl group, this phenyl group goes and attack this carbon and this bond goes to nitrogen. So we get CH3, CH2, C, C6H5, double bond N, and this negative charge goes and attack MgBr. MgBr. This is a product A, which is on further hydrolysis H3O plus, we get a ketone compound, that is CH3, CH2, C double bond O, C6H5, methane, ethane, propane, that is propiophenone. So the option 1 is correct.
To achieve gene silencing, which one of the following is used? RNA-I only, antisense RNA only, both A and B, none of the above. Where do we do gene silencing? If we want to silence any particular gene, which means the functional protein out of that particular gene shouldn't be produced, isn't it? In that case, we use either antisense technology or RNA-I, which is RNA interference. So what happens here? We know that central dogma is transcription and translation, isn't it? So DNA to mRNA is called transcription and mRNA to a functional protein is called translation. To disrupt this process, we use antisense technology where an oligonucleotide binds to the mRNA and RNase H will bring a nick or cut the RNA into pieces, which will further avoid formation of a functional protein. So the answer would be both A and B, that is RNA-I and antisense RNA. Consider the following statements regarding pollen grain of a flower. Okay, so they are spherical in shape. Yes or no? Pollen grains are spherical in shape. The outer layer is soft and known as exine. The outer layer is called as exine, but it is not soft. How is it? The outer layer would be hard and hard inner layer is known as intine. So here the error is, here it is soft and they are about 25 to 50 mm in diameter. No, so whenever a numerical value is given, you should be cautious about the unit. So here it is mu meter and not millimeter. Clear? So we have error in 2, 3 and 4. Choose the incorrect statement. So all these 3 are incorrect. So the option would be 2, 3 and 4. Which one of the following vitamins is synthesized by LAB? What is LAB? It is lactic acid bacteria. So where do we find lactic acid bacteria? Give an example. An example would be Lactobacillus, isn't it? So here they have given 4 vitamins which are all from vitamin B, and in the process where milk is converted into curd, what we do initially, we introduce a small amount of curd into the milk, isn't it? At optimum temperature, the bacteria present in that inoculum, the curd which we introduce initially is the inoculum, which will contain lot of lactobacillus, and those lactobacillus will convert the milk into curd where they will enrich the curd with vitamin B12. So which is vitamin B12 here? It is cobalamin. What are these? Vitamin B2 is riboflavin, vitamin B6 is pyridoxine and vitamin B5 is pantothenic acid, isn't it? So the correct option is cobalamin.
The relationship between fig tree and wasp is an example of. The options given are amensalism, mutualism, commensalism and parasitism. And these options are some of the population interaction. First, we need to know these definitions of these options. So, first, amensalism. We usually have two species, that is, for example, it is a species A and species B. In amensalism, one species get harmed and another species it's neither harmed or benefit. In mutualism, both the species get benefited, and in commensalism, one species get benefited and another one is not harmed, and in parasitism, one get benefited and another one is harmed. Here the question asked is, what is the relationship between the fig tree and wasp? Usually the fig trees are pollinated with the help of wasp, and this wasp usually lay eggs on fig trees. So by this we can conclude that they are mutually gets benefited. So they are mutually gets benefited. So the option 2 is the correct answer. The fig tree and wasp is an example of mutualism. Consider the following statement and choose the correct option. The statement 1 is DNA is a hydrophilic molecule and it can pass through the cell membrane. And the statement 2 here is DNA is negatively charged. Usually the DNA is a nucleic acid which is the water loving, hence they were called as hydrophilic. Okay, usually this DNA is negatively charged, but the cell membrane or hydrophobic molecules, they are water hating molecules, they are usually made up of lipids. Hence the DNA present inside cannot move throughout the cell membrane. So the option given state 1, the DNA is a hydrophobic molecule is correct, but it cannot pass through the membrane. So statement 1 is wrong. Statement 2, the DNA is negatively charged. So the statement 2 is correct. So the correct option is, first statement is incorrect but the second one is correct. Match the column 1 with the column 2 and choose the correct option. In column 1 they are given some of the phylums of animal kingdom, and in column 2 they have given their specialized characters. We need to match the correct one. First in column 1 they have given Platyhelminthes, Sethanophora and Coelenterata. First, in Platyhelminthes we usually possess the flame cells which is called as flame cells. It is usually present in Platyhelminthes, which is helpful for osmoregulation and in excretion. So flame cell is usually present in Platyhelminthes. Next, here we come comb cells. This comb cells is usually present in Sethanophora, which are present in 8 rows, and they were ciliated. That means they were present like a hair-like structure, which is usually present for locomotion. So So this comb cells are present in Sethanophora, and this syndoblast which is present in the Coelenterata, this is also called as the syndocytes, which is helpful for capturing of prey and for defense purposes and for anchorage, that is for supporting. So by this we conclude that Platyhelminthes possess flame cells and Sethanophora have comb plates and Coelenterata have syndoblast. So the correct option is option 2.